Well, I might as well get started right at the end of the song. Why not? So it's just 2 minutes past the hour, and I think we're ready to get started. I am Tim Erlin. I'm the VP of Product at Wallarm, and I want to say welcome, everyone. Thank you for joining us for this event. It's a quarterly event for us. This is our CISO briefing on our API threat stats report for the quarter, where we're going to focus on a number of issues, including AI security. And I am joined today by Ivan Novikov, our CEO and founder. So welcome, Ivan.
Hello, team, and welcome everyone who joined. Feel free to share the link with your colleagues and friends. It's right time to let more people in. And if you somehow missed this event or want to share it after the event, like through different time zones, so feel free to then share the link on LinkedIn, where you can always find the recording right after the event, as well as a live event.
Perfect. That's excellent. That takes care of half of the housekeeping items we have before we start. The other half relates to questions. So if you have questions as we go through the material, the presentation today, if you're joining us on Zoom, feel free to put them into the Q&A chat on Zoom. If you're on LinkedIn, feel free to pop your questions into the comments. We'll do our best to collect those as we go and find time to answer them either while we're talking or at the end as well. So please definitely add questions. We'd love to have an interactive webinar.
And don't forget to follow us on LinkedIn as well. So to get more reports timely and more insights, we're doing this quarterly. But on the top of that, we're the company, an API security company, I'm pushing a lot of other useful content, such as white papers and case studies and many different things. So to get the latest, always follow us on LinkedIn.
That's great. Thanks, Ivan. So just to give you a preview of what we're going to be talking about, so you have some expectations set, we'll spend a little bit of time talking about the methodology and purpose of the API threat stats report itself and why we do it. And then we'll dive into the data, looking at the breach trends, the vulnerability trends, the key findings and key takeaways as we go through. So that's what you have to look forward to. Ivan and I will divide up the presentation responsibilities, but we'll both jump in and comment as we go and hopefully make it interactive and more of a conversation. So to get started with, we do want to wish ourselves a happy birthday, I suppose. This is the 10th API threat stats report we've done. So it's a little bit of a trick here because it hasn't been 10 years, but it has been 10 reports, or if you prefer 10 quarters, because it's a quarterly report, in which we've been measuring the API threats in order to understand what real risk exists out there in the API threat landscape. Analysts like Gartner, they obviously say that the threat landscape is growing. We want to measure how it's growing and then deliver those insights. In this case, we measured 16 times faster than the OWASP API top 10. So we like OWASP, we're big fans, but OWASP updates not every quarter, significantly less frequently. So we want to make sure that we're updating the threat data faster than that. Looking at those real exploits and vulnerabilities, both in order to inform you folks about what's out there in the threat environment, but also in order to improve our own threat detection capabilities as we move forward. So 10 quarters of API threat stats report, and we hope for many more as we move into the future. So we'll start with that conversation about the methodology here. What is API threat stats? We collect a lot of data from our own platform. Wallarm detects attacks across a large number of customers, but we also collect data from public repositories and private sources as well. So that means all of the API related security bulletins that are published in a given quarter. We look at bug bounty reports, we look at API exploits. All of that data goes into the threat stats report in order to produce the output that we're talking about today. So it's important to us that this is a report based on facts, not on opinion. We're looking at data and performing analysis, not conducting surveys and reporting the results of other folks' opinions. And that methodology looks a little bit like this. Obviously, there's data collection at the start. We do filtering and normalization on that data so that we get it into a format that we can analyze. That analysis and classification is done in part in with automated methods using AI and also manual methods as well. And then those classified results, we perform our analysis and we publish them into that final report, which is what's available for download as of today and what we'll talk about in this webinar. And we do this work on a quarterly basis so that we can gain that real-time understanding, real-time analysis of the API attacks and threats that are out there. That allows us to constantly update what Wallarm is capable of doing. So this report, while we want to share it with the community, it also has a purpose in terms of improving our product. It also allows us to improve and extend those API risk models that we use in the product as well. So we think the data is valuable for the community. It's also valuable for us as a product vendor as we move ahead. Awesome. And then this is really the one-shot view of what's included in the report for this quarter. I'm not going to go through all these details. That's what the rest of the webinar is for. But I wanted to put this up there. It's included in the report, this sort of 5x5 matrix that talks about the breaches that occurred, the API breaches that occurred within the quarter, top 5 vulnerabilities, top 5 cloud native exploits, top 5 cybersecurity product API vulnerabilities, which is an interesting one, and also those enterprise API exploits as well. So there's plenty of risk and vulnerabilities to go around, and we're going to dive into the details in the report. And Ivan, I want to hand it off to you. I don't know if you want to add anything on this particular slide or if you want to jump into the breaches themselves.
Thank you, Tim. Now, just a few things to add here. So I eventually decided to move forward with this 5x5 matrix and put this into the very first pages of the report to give all the readers some sense of what's inside, and also sometimes catch your attention to some brands or vendors that you actually using. There is a Fortinet here, but it's not related to Fortinet bugs that happened literally yesterday, right? If you look at the news, you found that there is another one, right, related to also Fortinet Manager, but not EDR. So this is a bit different. What I really like about this is, like, you can find, first of all, 5 industries across where we run an analysis, right? Actually, it's 4 industries: AI, cloud native tools, cyber products, and enterprise software such as SAP, VMware, Oracle, DocuSign, and others. And also, we do have a data breaches from where we actually start to explain you what happened last quarter. And let's dig into it. Yeah, I like the slide, and I like this infographic to show you how this API issues and vulnerabilities is actually impactful. Starting with Deutsche Telekom, that got 250 million users leaked, at least compromised at some point. And this is very, very sizable thing, because it's all their users, so it's all they have, right? And what is most important here, if you try to get any data, any piece of information, what actually happened, many of the sources shows that the attack was actually performed in a very short period of time. So what's specifically unique about APIs is they designed to get data flow, in and out, and the time to actually exploit or compromise significant amount of data, such as 200 millions of users, right? It's actually took 5 to 10 minutes to download, let's say, 5 gigabytes of data at 100 requests per second. 100 requests per second is not really a lot. And many of these APIs designed to perform even higher speeds, right? The reality is, unlike any other threats in real world, APIs are basically designed to get data downloaded at very fast speed. That's why you don't really have 5 or 10 minutes to the mitigation, and the protection should happen in real time. And we have now confirmation from the real data breaches that point us to that point. So in other words, API security should be not even proactive and real. It should be real time, and it should block attacks when it happens before it causes damage, because damage can, even 5 minutes of exposed access can download an entire database in many cases. The other thing is a Hotjar. This is the most interesting, is it for me, because it's a client side. When we're talking about APIs, very rarely we're really talking about client-side security such as XSS, CSRF, and so on. And this is true. APIs not specifically designed to be used as a backends for browsers, right? When your client is a browser, but many cases such as mobile apps, or as in this case, web browsers still using APIs, and we have to include client-side security into this. Into the API security controls and measures. So the Hotjar also was very interesting exploit, because it posed some problems with the Business Insider with many, many users, 80 millions of readers, if you count just Business Insider users. And I assume that others also could be vulnerable. The next one is Explore Talent. The authorization for an API caused a breach of 11 millions of users. And next one is a Metro Pacific Tollway, or MPTC. API leak exposed like roughly 1 million users and all different records, which is a very interesting thing though. And as you can see, every single time when we explain something in the data breach that happened this quarter, it's completely different industry, right? Deutsche Telekom as telco, Hotjar, Business Insiders, kind of news, media, right? Explore Talent as a software as a service. MPCT, it's more transportation or, like kind of like infrastructure, right? Things. And fractional ID, the last one I want to explain, is a blockchain. The interesting thing is it's very representative because just in one quarter, we saw so many different industries vulnerable to actually API exploits and API issues and the data breach. And we only can count what we know, right? Ultimately, month over month, we'll see more reports and more like disclosures related to data breaches that happened in Q3. For now, it's only like 5 of them, which is still a significant amount if to count users, right? 350 million users. That's a lot. It's almost equal to the United States, population, right? And that's just a lot of the users that compromised. What is important here is, again, like the same root causes as usual, right? Authentication flows, kind of new things with the client-side attacks, but we mentioned that client-side caused a lot of API impact quarter over quarter, at least last year. We mentioned this client-side many times during the ThreatStats report. Authorization issues and obviously API leaks. When you design the API in the right way and if you put all this right controls, such as authentication, authorization, but it's just leaked by data, such as like expose a little bit more than it's supposed to, or expose a little bit more than it's designed for. Next slide.
So I want to point out on this slide, you mentioned the multiple industries that have been affected. It's important to understand that the impact of API risk isn't limited to specific verticals or specific industries. It's a truly horizontal problem because the technology is truly horizontal. So just because we've seen telecom, transportation, media, and technology doesn't mean that next quarter it won't be a completely different or overlapping set of impacted industries by breaches. They happen every quarter across industries.
Correct. And the right statement here is APIs are everywhere already, right? APIs are kind of new wires. Whatever system you build, from like smart city to just like connected car, you need an API to get this thing connected to the mothership, right? To the data center. And that's happened everywhere. So I assume even now, while we talk in Zoom, right, the Zoom uses an API to stream our data and get the feedback from our audience as their Q&A. By the way, there is a way for you to ask your question on Zoom. Just feel free to use this option, and we will explain, unpack, and then make kind of responses to your questions after the event. Okay, what kind of type of data breaches actually surprised us in general while we analyzing threats this quarter in Q3? So first of all, it's a client-side API vulnerabilities. It exposed the hidden risk. Why risk is hidden? First of all, because this is not a part of the usual OWASP API top 10. They excluded this risk, as well as injections, by the way, which I assume was a big mistake. Because of that, developers don't care. In many cases, I personally talked to developers of the API backends, and they said, hey, client-side is not up to us, it's for JavaScript. So we don't care. The other thing is the misconfiguration that amplify data breach at scale. When I'm talking about misconf, I mainly mean, let's say, thresholds, rate limiting, and all the other controls that cannot directly prevent the breach, but they can prevent the exploitability or kind of like build a kill chain or download the data after the breach was found. And the last one is API is a common weak link across diverse industries. As we covered with Tim before, you can see, telco and blockchain in one bucket, right? And it's very rarely to see some kind of like attack or vulnerability that covers that many different industries, usually because like telco built dozens of years ago, right? And then blockchain just recently. And it's not that many, similar between them. Cloud security is not similar, right? API, very similar. And it's very, very insightful and also point us to the main idea of, how broader this API security actually define the cyber landscape and cyber threats. Tim, do you want to add something?
Yeah, you gave the example of Deutsche Telekom and how fast the data could be downloaded over an API. All of that effort that developers have spent making their APIs performant is beneficial to attackers too. So when we talk about misconfigurations, that reminds me of the rate limiting as an example. So if you have an API that supplies data, understanding how that data should be supplied in an operational production environment versus an attacker who's trying to scrape it all, that would be an example of a misconfiguration where that amplifies the scale of that breach because of the speed at which the data can be downloaded.
Yeah, you're absolutely right. And moreover, attackers' behavior completely changed, right? A couple of years ago, we mainly discussed about, hidden threats and APT when they get a data breach and never, like try to raise their hand until they build a whole kill chain. And with APIs, it's completely opposite. The vulnerability is here, the data is here. It's super beneficial for attackers to download all the data at a very short period of time before the other side, defenders like us, right, will able to mitigate and roll out controls, because ultimately there is just so many different things to find you, right, identify you when you get into, and it's hard to stop you when you have an access at very short period of time. So attackers change behavior from very silent and slow, like smart guys to like all in one, 5 minutes I will use it in full, right?
Right. Yeah. So let's shift from the breaches that occurred, the incidents that occurred in the quarter, and take a look at the vulnerabilities that we've analyzed for Q3.
Yeah. First of all, because all the data breach, right, have some vulnerability under the hood, right? This quarter we got almost double, like 96% up in terms of API-related CVEs, and we also analyzing bug bounty reports. So why we're doing this? As you know, data breaches, with the data related to data breaches don't actually happen very, 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 timely. Sometimes you can learn that data breach happened in a year or quarter after it happened. So CVEs and vulnerabilities are very, very timeless. It's basically days until before it's discovery and CVE assigned for chunk of them where a CVE is assigned. So this quarter we got almost double, which is very interesting number. 400 means, count how many a day, right? More than 10 a day. And when we just started 2.5 years ago, it was less than 3 a day. Now it's about 10, so triple, even more than triple in 2.5 years, and double this quarter. It's very significant number. As you can see, the trend was there, and it's a quarter-over-quarter, year-over-year thing, right? So Q3 2022, Q3 2023, and Q3 2024. And then I can say that Q3 usually is the most productive quarter in terms of how CV is assigned. I guess it's more about the summer season and how researchers actually submit bugs. I know at least a few researchers that collect bugs and submit after the summer season to don't spend their time during this stuff. But it is what it is, right? We have a trend. The trend is growing, and what is most important here is we don't see the plateau. We see the clear acceleration of the growth. So we don't know to where it goes, but having something double quarter over quarter means that you cannot predict next quarter, right? It could be triple more, it could be 2 times more, it could be 10% more. We'll definitely will be able to see very interesting Q4. And for us, it means very interesting annual report, because we're not doing Q4, right? We're pushing this annual reports.
Yeah, and just to fill in a little bit of data here, because you and I were talking about it before the webinar, since this is our 10th report, the first report we did in Q1 of 2022 was 48 vulnerabilities, if I remember. So that 48 now to 469 is a huge increase. But your point about the pattern that it's not a linear increase is really interesting. It makes us unable to predict what's likely to happen next. But there's clear trend for growth. And I tend to think about the breaches as examples of realized risk, right? So that's risk that actually was exploited, and the vulnerabilities as unrealized risk. So this is potential risk. All of these vulnerabilities that are out there are potential risk for future incidents, for future breaches that might occur.
That's correct. And it also will be interesting to see how this correlates with overall total amount of CVEs assigned quarter over quarter to get what's the API chunk, because I definitely see the relative amount of this APIs inside all the CVEs growing as well. And I feel that amount of CVEs assigned also growing up. And the only reason of this is just more researchers now have ChatGPT, to explain their CVEs and assign numbers. And before that, they were just lazy to even assign the CVE numbers. To the next slide. Okay, so that's my favorite slide, and the most interesting part here is just to explain the nature of the API vulnerability. So the average score, the basically significant amount of this CVEs related to APIs got 7.5 score, and it's not in a random number, as you can see here. The distribution is very, it's very, very biased to 7.5. So why 7.5 into the middle, and why we do have more than 200 issues, roughly half of this, all the issues, right, related to 7.5? And answer is here. So to get the 7.5, it's essentially two ways how to get that, right? By impact and by exploitability score. So in reality, all the API issues that we analyze this quarter and before to 2.5, almost 3 years when we're doing this research, we see one pattern. So the exploitability score is very high because it's easy to exploit APIs because they're designed to be accessed, right? They're designed to be connected to different systems. They never designed to be somewhere inside with no access and so on, right? They're exposed, in other words, in different form, right, by default. That's why exploitability score is very high. And impact score is different. That's why we have a full set of different things. If impact is very, very high, then we have, higher score. If impact is moderate, we have 7.5. Moderate impact multiplied by high exploitability give us exactly 7.5, where we have significant amount of API vulnerabilities by CVSS. And it's a clear answer that also bring out to the point that no matter how big is the risk, you have to take care about the API security and API exploit, because most likely you will have this issue.
So let's talk about the types of products that are vulnerable. You mentioned this a little bit earlier, but this is the breakdown in terms of different types and where the percentages lie for Q3.
Yes, and I got the question about the quality.
No, now we can't hear you, Ivan.
Yeah, no, now you can, right?
Now we can.
Okay. The best quality I can do today. Sorry, guys. What type of products are vulnerable? So what we're doing with this research, we also try to find a way to split products by categories to at least navigate and guide through different types of issues across different industries. What is the most interesting for us now is we see constant growth of AI or machine learning software and hardware as an independent category. We never spend attention to this category until probably Q1 this year, when we got first 5 or significant amount of exploits among the overall amount. So it was 1.5% and 2%, now 3.2%. So more and more exploits specifically related to AI APIs in our analysis are related to CVEs. And again, we're only talking about AI exploits related to APIs. I assume that there is a significant amount of AI exploits or AI vulnerabilities not related to APIs or their APIs. And as usual, enterprise hardware and DevOps tools took the majority. They kind of switched to each other. Why it happened this way? First of all, because enterprise software heavily driven by APIs. I agree, mainly all of them legacy APIs such as SOAP, XML, RPC, and so on. It's not necessary to have GraphQL there, but it's still the case that enterprise software completely driven by APIs. And the DevOps tools, like tools such as Kubernetes, tools such as CI/CD tools, they all based on APIs. They basically don't have anything else. There we're talking about more modern protocols such as gRPC, GraphQL, and others, but they're also vulnerable. So again, it's not that many in common between DevOps tools and enterprise software means legacy, but APIs. And it's very interesting observation that I still, like, kind of make me very curious about the reason of this quarter over quarter. This happens every single time when we started from 10 quarters before to now. We always have this one. So enterprise software and DevOps tools, they heavily driven by APIs. That's why significant amount of all the CVs and bug bounty reports related to APIs point us directly to there. But AI is definitely a new threat that's growing very, very heavily. The next slide.
So we can move from some of the data into what our key findings are here. We've looked at sort of the data breakdown. Let's talk about those key findings. And we can start with eBPF. And Ivan, I think it would be worthwhile to start by explaining what eBPF is and why it's important.
Yeah, as you know, eBPF is my favorite topic because I really don't get the, this idea to reduce security and get something like syscalls into the user space. So reality is a little bit different. So first of all, in many cases, when you think about eBPF, you really think about Cilium as a kind of like all-in-one framework and a software that pretty much everyone using to get some kind of eBPF experience. And I guess significant amount of product is cybersecurity products built with eBPF, use Cilium, if not all of them. And as you know, company recently got acquired. This quarter, we got roughly 3 or 5 different CVEs specifically related to Cilium. And all of them very, very risky and very impactful. And again, because this is direct access to kernel, having something in user space that communicate to the kernel in this way, like intercepting syscalls and having the low-level ops, it's not secure by default, right? That's why we have more and more things. The other thing that basically catch my interest is as CrowdStrike eBPF. We all know about the CrowdStrike Windows, kind of like blue screen of death thing that definitely happened. I don't really want to spend time on this, but at the same time, CrowdStrike's eBPF agent also caused crash, which basically caused kernel panics across many, if not all, the Linux systems, even if it was not, that famous and mentioned that many times in media, but in fact it happened, and that sensors caused crashes on Linux system because of eBPF. Only these two things with Cilium and CrowdStrike should, point us to the real state of security of eBPF, which I'm sure should be improved. And I'll not be surprised if very soon Linux community will get rid out of eBPF as a whole thing, because it's so many different concerns from different things. But we will see.
So the interesting thing here is that you've got two completely separate events that are related to eBPF. So this CrowdStrike issue with kernel panics because of eBPF, and these Cilium vulnerabilities, which, as we talked about before, vulnerabilities are potential risk that hasn't necessarily been realized yet, and that points to a trend or a potential trend around eBPF being essentially an attack vector for attackers.
Yeah, that's all correct. And again, in the full report, you can find the dedicated page where we put many different issues related to eBPF for the last, I guess, a year or so. So it's more data in the report. If you're really interested in how eBPF actually insecure, you can download full report and get more data there.
So we brought up earlier in the conversation the trend towards client-side API vulnerabilities being impactful in the breaches that we analyzed. But there's also, a trend here around vulnerabilities that we need to pay attention to. So let's start by just distinguishing between the difference between when we say client-side vulnerabilities, API vulnerabilities versus server-side API vulnerabilities. What's that difference mean, Ivan? How should people look at that?
That's a very interesting question. And the the kind of split between client side and server side happened even before, API took the web world, when we just used, ACE HTML and dynamic content that was kind of like JavaScript or client side happen in a browser, and also server side, which essentially was not clearly API, but also returned some kind of like client side code. And that times, 10 years ago, 20 years ago, 30 years ago, I guess 20, 30 years ago, more than 10, it was completely usual to have a server-side bug that cause problems on a client side, right? Such as XSS, stored XSS, right, where you store some data and host it and serve. So then the times change, and now we have completely clear divider between the backends, which is mainly APIs, in our case here for sure APIs, and the client side, which means independent apps, not necessarily JavaScript. It could be mobile app, which now I guess client number one for many businesses, right? Still using different controls, still your client. So when we're talking about client-side security, we essentially talking about vulnerabilities that somehow happen. The root cause of this vulnerability happen on the backend side and the API side, but they cause an impact only for your clients. In other words, using this type of vulnerability, it is impossible to compromise your database, but it's possible to compromise all your clients or particular group of your clients, which using this clients, such as mobile browser or mobile app or web browser or other clients, it could be thin clients or whatever, right? As to access to your API, right? And then the interesting part here is that not all the time these clients even use any UX, right? We usually think about browser or mobile app, right, as something with UX, with the forms and images and the buttons that you can click and so on. However, API clients could be other APIs, right? And then some API to API integration could be some legacy systems, and even code, such as some other backends or apps not directly having APIs, right? Your API client is essentially everything that can connect to API and consume data, and sometimes it could be even the legacy apps, right? And that was the divider, right? Basically by an impact by the target. If your target, if target of this attack is clients and only clients and their data on their side, right? Such as I'm making an exploit that download the data or steal my tokens directly from my compromised user browser, not from the backend, it's a client-side attack, something that happened on the client side. But narrow thing here is these attacks happen because of the bug on the server side in this API. That's why we should not discount client-side vulnerabilities while we're talking about API security.
And so we've seen a couple of examples in the incidents that occurred in Q3. We expect to see more, but why do you think client-side vulnerabilities have been maybe not ignored entirely, but underrepresented when we talk about API risk so far?
I mean, the first reason is OWASP, right? OWASP API top 10 became a kind of first thing that developers and cyber experts looking for, and the client side is not there. And second thing, I guess, because client side is something that happened for a while, and all the time when we haven't this as a risk, it point us, emotionally to something that all in legacy not related to APIs. I guess it's more about, kind of perception. But in reality, if you build an API, right, for what you build it? You build it for some client, right? It's in general. You're not building it to don't consume, right? Someone will consume it. Two things, right? First idea, you build it for yourself, and you yourself or your APIs, your clients. Then client-side security getting kind of like less important for you because you don't have outside clients that could be compromised. You control them all, right? And an API that expose something to the world or your partners, right? If it's like the chunk of the world, right? Not the global world, it's still assume that the clients exist. So you should consider about this clients and their security as a part of your own, because again, it's not good to get them compromised because of your backends, which should happen. I guess that's why API security is a relatively new thing. It's a part of AppSec, and then securing interfaces for applications was on the map a while ago. And I guess it's more about how we think this attacks look like, and also cases, right? It's not that many times when APIs get hacked this way. And then when we're talking about OAuth or single sign-on, it's usually counts as something different, right? If you look at this OAuth exploits or ask your developers, hey, do you think you know about OAuth threats, right? They tell, hey, we know, and list them 1, 2, 3, 5, right? The bad redirects and so on. And they will list you 5 top client-side issues, such as open redirect, insecure storage of the secrets at the client side, and blah, blah, blah. So they essentially have this in their mind, but never mention this directly as a client side. However, it's a client side.
Yeah. Okay. That makes sense. That makes sense. So we see client-side API vulnerabilities as one of the key findings, one of the key trends. And then the last key trend that we have, which is maybe the most interesting, most important, is around AI security. And we found ourselves saying that API security really is AI security. And I wanted to start here by putting up just the summary of the OWASP LLM top 10 and the OWASP API top 10. Because it's really, when you put them side by side, it's easy to see how they're related and how they're different. And I think, Ivan, this is a topic that we've talked about internally quite a lot, that the LLM top 10, while it covers some of the novel risks associated with LLMs, a lot of the risks associated with LLMs are really covered by that API top 10 because they're all based on APIs ultimately. Like AI security is API security and vice versa.
Yes.
Where do you see the gaps here?
Yeah, that's very interesting angle, by the way. First of all, LLM here on the left, I guess not necessarily represents an entire LLM, also kind of AI APIs. When you see this, like LLM 07, such as insecure plugin design, it assumes that your LLM support plugins, but essentially only OpenAI API support plugins. It's not directly LLMs that supports plugin, but API. So many different things on the left, by default, assuming some APIs. And not just mentions there, right? Or supply chain. Which kind of supply chain you mean? Mainly supply chain connected to your LLM via API. It's not other ways. There is no other way to connect data to your LLM without this, right? It's very, very important thing. And on the right, we have kind of like risks associated with very specific set of APIs, right? Ultimately, many of this risk on the left, such as insecure plugin design or sensitive information disclosure, they should and only can happen via APIs, right? There is no way for LLM to get sensitive information disclosure. I'm talking LLM 06 with no API. Essentially, it's exactly an API risk. So I guess what is interesting here is to see how many of this risk on the left directly related to APIs and only accessible via APIs, and how many of them indirectly or somehow else related or completely non-related to APIs. That's, I guess, what we should do, right? Even prompt injection, right? How to get the prompt? You use an API to get the prompt. It's exactly API injection.
And we've talked about the fact that injections in the OWASP API top 10, injections used to have their own category, and they got moved into this API 10 unsafe API calls. You could certainly put prompt injection in as an unsafe API call. Like it's almost a perfect mapping if you wanted to follow that. And as you pointed out, sensitive information disclosure, LLM 06, API 06 is unrestricted access to sensitive data. They're very similar in those cases. But things like training data poisoning, that's pretty specific to LLMs. You can't, there's no training data in a generic API, but you would still potentially conduct that training data poisoning via an API and maybe even leveraging one of the API top 10 risks in order to do it.
Yeah, I agree. And essentially, like if you're talking about this LLM or AI security, right? While building this, and by the way, I really like that it's called LLM, not AI security, because AI it's basically more equal to APIs than just LLM, which is a very specific thing related to only large language models. And then, yeah, I expected to see threats such as like language specific, right? Large language model specific, because I feel that all the threats on the left related to the broader group of of models, not only LLMs. But you're right? To get LLM somehow exposed to the real world and the user, you need an API. That's why many of the threats, I guess 60% of them, 6 of 10, directly related to APIs, and some of them not directly related.
Yeah, yeah. So we can move on to sort of a summary there, in this on this topic, and look at sort of those top issues that affect both, that sort of draw the line between the straight line between API security and AI security, and so this is what they look like, right?
Yeah, what we did this quarter, we analyzed all these API issues related to AI products, including LLM and infrastructure products for AI, such as OpenShift AI, right? Platforms that allow you to run this AI, including NVIDIA hardware and software and firmware, everything related to AI, not specifically LLMs, which is a subset of that, very specific subset. And what we found as number one is injections, right? So injections cause more issues than other things, and also they're more impactful. The second is authentication and access control flows. And I specifically put authentication and access control in one category rather than authorization, because in many cases we actually didn't see broken authentication authorization at all, or missed authorization. We only see kind of role-based access control issues or authentication where you cannot identify who your customer, who your client is. The third thing is configuration crypto failures. The crypto failures group with confs to represent the broader group here, because again, we didn't see a lot of this AI API issues in a quarter. I guess at the year scale or 2-year scale, we will get more data and can split it by more groups. Crypto failures is very interesting here, because to let this AI doing something, we need to configure the crypto keys, authorization keys, and some other things that directly relate to how we store them, how we secure that, how we consume it, and how that stuff overall encrypted if needed. And the last thing is specifically related to client-side API issues, such as, I guess, misconfigured OAuth tokens or insecure using OAuth token by clients, right? Or insecure using of this GVT tokens by client, but you issuing the token, assuming that someone can use it in an insecure way, and you should not allow to do this, right? You should apply more controls to make your token secure and implement more, protection than usual, because you again know that your clients consume your keys or your APIs by their browser or mobile apps in very specific ways. So that's the thing. Yeah,
good. Okay, so we can move on to our sort of key takeaways overall. Before we do that, there are a couple of questions that have come in, so we can answer those questions, then we'll move on to the key takeaways. The first question here is, when your company is 100% SaaS based and you develop software to utilize those vendors' APIs, what's the best way to protect the company when the vendor's API is a black box? How can I perform security on the APIs? Ivan, do you understand the question? Do you want to try and answer it, or do you want me to?
Yeah, I guess I understand the question. And software as a service by default means API first, right? Because to make something as a service, you have to expose an API. Is it correct? Do you agree with that?
Yeah.
Then this is an answer, right? it's the first thing that you should do. Make sure that you know all these APIs that serve your customers or you as a service, subscriptions, and start to utilize as many controls for that security as you can. Starting with headering, I guess, and simple threat limiter.
I think if you imagine the scenario is, I've got an external third-party API that I'm interacting with, and I'm sharing my data with them because I've partnered with them, I'm using it. How do I protect that? There are two things that come to mind for me. One is you can monitor the egress traffic from your organization potentially to that API. But then, you also have to, as with any third party, you have to put in place the controls for, third-party risk management, ask the right questions, or require those security controls be in place. What are they doing to secure their APIs? How do they manage, things like rate limiting as an example. So if you don't have control over that API, it might be that there are sort of traditional methods of third-party risk management to help there as well. The second question we got here was, does this work in conjunction with a SaaS API gateway? And I think that's a question about the Wallarm product. While this webinar is not specifically about the Wallarm product, I'm happy to answer the question. So yes, Wallarm integrates with API gateways to collect and analyze traffic, so we can detect and block attacks and do so through or with your API gateway as well. There's lots of information in our documentation at docs.wallarm.com about the different methods of deploying and integrating with the tools that you already have. So with that, we'll move on to the key takeaways. In the report this year, or this quarter rather, we've broken down the key takeaways into 3 personas essentially. So these are aligned in terms of their overall, objectives, but designed to sort of apply to the different personas as you go. So the CISO, the API architect, the security practitioner, but there are themes across them. And I think, Ivan, do you want to dive into some of those themes that we saw in terms of key takeaways?
Yeah, so first of all, this is the first time when we added API architect as a role, right, into the report insights section, and mainly because customers and our readers asking us to do so. So for them specifically, the difference between them and others is they try to build a kind of like APIs and apply controls proactively. CISO is mainly thinking about global things such as like, hey, how do we establish the policy that will work for us for years, and how to deal with something that's already built, right? Architect, unlike others, can improve the security proactively. They can integrate controls and something that basically will work for them for years, even before they get faced with these issues. And security practitioner can only see what's actually exposed, right? They mainly focus on exploits and, what we tried to explain before about like how fast an API data breach could be exploited to get the real data. So the most interesting piece here is that for me, it's first of all, look at this API architect thing, because even if you're not an architect, you will see all the proactive controls that you can check your system, your APIs with, to measure if you have that done or not, to understand the real risks that exposed right now, regardless of your controls, regardless of your policies, regardless of like who's running a pen test. You can find out if you do have authentication across all your APIs, yes or no. If you have input validation such as hardening, right, schema enforcement for input and output both, right, yes or no. If you have prevent mass assignment, it means that you control all the parameters and only these parameters can be passed through. Right? If you design app level or API level, I mean, API just interface for application. I'm talking application as a business logic piece, right? Rate limiting mechanism, and not only about IP addresses, right? It's more about, hey, how many orders per minute, per day, per over time you allow, right, your users, such as your consumer or e-commerce user, to make, right? If you don't have limits, don't expect that they will not be abused, right? And how to integrate AI APIs with your security flow, because essentially it's the same thing. You have a lot of this AI that your APIs will consume, and you have to think about how to secure data, how to sanitize inputs from users to their API, how to don't allow them to use more than design and so on. I really like this middle API architect role here, because it's the only thing and the first time when we push proactive controls rather than kind of checks and integrated things on the left and right.
And what's interesting about that API architect role, because we were just talking about that question around third-party SaaS, right? The API architect recommendations here also make a pretty good checklist for asking a third party, do they do these things? Did they build them into their APIs? Do they, ensure that there's authentication across all of them? How do they do that? Are they doing input validation? How are they preventing mass assignment? Those are the controls that you would want built in up front, and they actually make a great start of a questionnaire for a third-party provider as well. So there's much more detail about each of these recommendations in the report itself. So if you want to dive into that detail behind the recommendations on a persona by persona basis, definitely download the report and take a look at all the details. So this is how you can download the report. You can always find it at wallarm.com/resources. There is a QR code there. There's also, if you're on watching on LinkedIn, there's a link in the comments as well. So the full report is accessible there. If you have any last questions for us, now's a good time to put them into the Q&A or in the chat. And then we also have a next webinar coming up. We always have a next webinar coming up. In this case, we're going to focus a little more on the Wallarm product itself and how you can really gain security context with API session data. So looking at the sessions and the telemetry you can get from sessions in order to gain that security context. We'll have our field CTO, Tim Ebers, and product manager, Raymond Kirk, hosting that webinar. So that takes us through all of the data on the API ThreatStats Q3 2024. Lots of interesting, exciting tidbits in there, interesting trends to look at that we expect to continue analyzing into the next year and beyond. Ivan, I want to thank you for your time and expertise. I think it was really valuable and interesting, and as always, helpful to have your insights there. And I don't see any additional questions. If you have them, again, put them in the comments on LinkedIn. We'll go back through and look for questions there. Otherwise, I want to thank everyone for spending time with us. I hope it was interesting and informative for you. It was fun for us as well. Thanks.
Thanks, everyone, and see you next time with a different topic. Don't forget to download the report, but what is most important for us, if you really like the report, share this across your social media. We really need to get this report, to spread across the professional network. And it's nothing for you, but a lot for us, right? We'll definitely count this as an appreciation of our work. Put this to your social media, X, Twitter, whatever you use, LinkedIn for sure, and we'll really, really appreciate it. It will motivate us to run more reports like that.
Thanks, everyone.
Yeah.